All right, more of the same, changing whole numbers to improper fractions. What does 6 become? Tyler. Right, keep it simple. What about 12? Amanda. Great, 101. Kyan. Okay, good, at 26. Alexandra. Great. Okay, now what you had to do here, and I noticed that the directions were maybe a little bit confusing because of the way they lay it out. These two fractions, 3/4 and 2/5, we want to make LCD as lowest common denominator. We want a number that 4 and 5 go into, and we want the lowest number that 4 and 5 go into. But automatically, when you think about this, the number's got to be at least 5 or greater. So start there. Will 5 go into 5, right? Will 5 go into 5?
Oh, yeah.
It will, but 4 doesn't. So what's the first number you come into, or you come to that both 4 and 5 go into? Well, yes, it's 20. And then once you've established that 20, it's 4 corners again, like we did in ratios. You're making equivalent ratios, or in this case, equivalent fractions, for 3/4 and 2/5. Find what the constant is and apply it to the top. All right, what do you get? Lucas Longo, 3/4 becomes what? Squeezing this in here, but yes, 8/20, 15/20, and 8/20. Okay? What about 10 and 5? This is one of those instances where if you multiply the two denominators together, you get a common denominator, but not the lowest. Luke Soresco. Yeah, 10 is the lowest, because 10 can go into 10. It's a factor of 1. 5/10 is, Luke, finish it up, bud. 5/10 is, right, no change, times 1. Yep. And what about 4/6 and 2/3? 4/6 is, it stays the same. Then 2/3 becomes, did you get it? Want to do it now? He's right. Yep, 2 times 2. 2 times. Okay? Now that we have like an extra day before the test, I want to practice, it'll give us more time to practice things like this, the necessary skills to do fractions. We could take an extra day also, because I know some of you have been asking, how do you change those mixed numbers into improper fractions? We could probably use a day of practice of that, which is good, because it's skills that you need to do in order to build your models on your number lines. Okay? The last big concept now, though, as you'll see when you do this, this is the first occasion where you are going to have a fraction being divided by a larger fraction. Small fraction divided by big fraction. Okay? We're going to model it the same exact way. And then once you see it once, I think that you're going to be okay to work through a couple of these problems on your own. First things first, read the word problem. Tell me what is going into what. Or let's do it this way. What's the division expression? What divided by what? Sometimes this helps. Can I have 6 friends? Can 5 people be my friend? Tyler, you be my friend. Come on up. Elle, come on up.
I can be your friend.
Alexander, come up.
Melissa, I can be your friend. I'm not friendly. I could use a friend.
How many friends do we have all together?
3.
We got 5. I need one more. Hi, you be my friend.
Mr. Leslie, I can be your friend, Mr. Leslie.
Amanda, be my friend. Maybe.
What? Why are you stealing
I don't have trail mix, so I'll have to use Skittles. Except I don't have a whole bag. I need how much of this? 3/4.
Mr. Leslie, to be honest with you, I will gladly eat that as your friend.
I'm gonna take out how much? How much? Second roll.
You can have it. Eat it.
No, it went on the floor.
I don't care.
Throw it out. I'll give you another one. I have too late now. All right, let's make believe that's a quarter being removed. Don't touch this, Joe. 3/4, right? I'm afraid to have somebody hold on to this. Just hold on to it, but don't open it. Sit. 3/4. Listen, your name's not Maria, but just make believe you're Maria. Hi, Maria. She's got to split it. He's got to split it with 6 friends. So now that you kind of see it, well, how would you write it as a division problem? Is it 6 being divided up, 6 divided by 3/4, or is it 3/4 divided by 6?
3/4.
He's got 3/4 trail mix skills, whatever you want to call it. And he's got to give it equally, share equally with these 6 friends. So when you write it as a division statement, is it 6 divided by 3/4 or 3/4 divided by 6? Because every year this is problematic on that test. You got to put it into your head first before you can put it onto paper. Let's vote. How many say it's 3/4 divided by 6? How many say 6 divided by 3/4? How many say, go back, how many say 3/4 divided by 6? All right, majority of you have it right. Because think of it this way too. If you do 6 divided by 3/4, if you do that, you're going to get a value greater than 1. And that's not a value greater than 1. It's already 3/4. So we're divvying that up, that 3/4 being divided by 6, which means everybody's going to get a smaller portion than 3/4. You got to kind of see how it's going to work out in words in your head before you can put it on paper. So I promised. Open up your hands. Let me pause this because we're live. All right, back to the lesson. Back to the lesson. 3/4 divided by 6 is the correct expression. Or it's asking how many 6s in 3/4. See, it's one of those, this is the first time where you've got the bigger number going into the smaller number. Doesn't matter. Come on, focus. Focus. So now that I've kind of modeled it with the candy, will the answer be, well, what did everybody get? Did they get less than a bag or more than one bag? Less or more? Say it. Less. Yeah. No, thank you. Okay. We're going to model it the same way as we modeled the previous lessons using a number line. Yeah, Mike. Well, 6 into 3/4 is the same thing as 3/4 divided by 6. Let me get back to it. There are other ways to do it. There's definitely other ways to do it. There are. It helps us to see it on the number line, and then like in anything, there are shortcuts which I will eventually. You'll actually lead yourself to it. You'll see it. Okay. I have 6 and I have 3/4. Write it in the blank space because before we can do anything, we need to create. Well, we need to create what? Before we can model it on a number line, we've got to do 2 things. What's the first thing you got to do to the 6? Before you even do that, though, what do you got to do to the 6?
You have to make it,
Right, you have to make it improper, so make it 6 over 1. This is why we had to do this, the next step is the reason why we had to do this in the warm-up. Because Alexander's right. Now we need to create fractions that have the same denominator. Well, I got a 1 and a 4. What's the smallest number that both go into? Pi. 4. We only need to change our 6 over 1 because this one's fine. We already have fourths. What's our new fraction become for 6 over 1? Equivalent fraction for 6 over 1 with a denominator of 4. Amanda, 24 over 4. So now we're being asked to find how many 24 fourths in 3 fourths. All right, a lot of numbering, but let's do it. 0, 1 fourth, 2 fourths, 3 fourths. I'm going to pausing. I want you to think about this before you answer it, okay? Where is my go-to? Becca. How many say 24 fourths? How many say 3 fourths? 50-50 split, right?
Yeah.
I kind of mentioned to you back in lesson 2, and you might have forgotten. Once you have your how many this in this, no matter what, this never changes. Your go-to is always your second fraction. So 3 fourths is my go-to. That's what makes this lesson different from lesson 2. Because in lesson 2, you had big number divided by small number. Now you got small number divided by big number. So your go-to is way back over here on the number line. Kind of wanted to do that in red, but okay. Yeah, there's my go-to. Okay, so what's my leap by? This is my go. Obviously, then, this is my leap, right? Do you see that first leap? Well, let me ask you, is that first leap a complete leap?
Yeah.
It's automatically a partial leap. Lucas, it is. Because if I take my leap of 24 and my destination is before that endpoint of 24, it's a partial leap all the way.
I thought you meant that, but I thought you meant if it makes it all the way.
And that's going to yield an answer less than 1, which is what it needs to be. This is one of those problems where the answer is less than 1. I want to know how much. Follow the same methodology as you did with partial leaps. Steppy, what do you have? How much? Not 2 fourths. Amanda? No? You're close though. You almost had it. Close. Gabby. How many see that it's 3 24ths? Let me show it to you. Ready? To get that first leap, how many total steps? How many lines to get to that leap? 24 possible, but my destination or my go-to is 3 lines away. 3 24ths. Which does reduce to 1/8, but don't let that bog down your thinking right now. If you leave it 3 24ths and see why it's 3 24ths, that's fine with that. This is why this is nothing like we've done up to this point. All of your answers, if this helps you, all of your answers in, well, please. Although that was pretty good. All of your answers in lesson 4, rule of thumb, is going to be values less than 1. Let's do one more together. I think we need to do one more together. By the way, 3/24 or 1/8 if you simplify it. I don't know if I want to do H and I right now. Skip it for now. Let's go to the next one. Okay, let's do number 2. Okay, so imagine you have 2/5 of a cup of frosting. Sorry, I don't have frosting. I'm not going to take it out of the drawer.
Oh, frosting.
I'm sure you will. 2/5 of a cup of frosting that you need to share equally between 3 desserts. How much frosting does each dessert get? Well, you got to write it as a division statement first. What is it? Is it 2/5 divided by 3 or 3 divided by 2/5? Well, Alexandra. Right, it's smaller number being divided by the bigger number. I have 2/5 frosting. I've got to divide it up into cupcake. I'm 2/5. Make believe I'm 2/5. Cupcake or dessert, cupcake. I got to take my 2/5 and divide it into 3 desserts. 2/5 divided by 3. Which is the same as how many 3s are in 2/5. Answer, greater than 1 or less than 1. Joe D. Yep. That's it. Okay, now we know what's divided by what. We've got to make common denominators. All right, what's first? What's first? What do you do first? Come on, guys, think. Come on. I got 3 hands up. 3.5. 3.5. That's 4. Moose, do what first, bud? You had your hand up, right? What do you do first? Good. Then what? Which is? Keep that 2/5, right? 3/1 becomes what over 5? Good. How many 15/5 in 3/5? Number in fifths. You go. Where's my go-to? More hands this time, which is good. Michael. Agreed. 3/5. The line there. Oh, I'm sorry. Yeah, I got it wrong here, and I got it wrong here. Well, I'll erase this. This is 2/5. Okay. All good? All right, leap by. Leap by. Amanda. Yep. Makes that first and only leap partial. Can you figure it out?
No. Yes.
think of it as how many lines in the entire partial leap. That's your bottom. And your top is how many lines your destination is from 0.
I know what that helps a lot. Thank you.
Okay? Go ahead, go.
3 over 15? No, 2 over 15.
2 over 15.
2.
2/15 is my answer. Okay, I'll show it to you. You remember back in lesson 1, if you had the common denominators, you could just divide the numerators? I'll show it to you. My common denominator is 5, so I'm going to be concerned with my 2 and my 15. Do you have room? Because I don't.
I have room.
There's a little room at the bottom. So now, it's 5 into 2, right? Oh, I'm sorry, 15 into 2. Watch how simple this is. You're going to be like, wait, what? You're going to be like, wait, what? Can 15 go into 2?
Yeah. Oh.
No, right? Normally when we did decimals, you got to add the decimal and 2 zeros. Ready? 15 can't go into 2, right? My remainder is 2. My outside number is 15. I'm done.
What? Whoa. Wait, that was H? No.
That's H.
So easy.
You make common denominators, it'll work every single time.
You can just do that.
Sometimes you have to reduce it, but yeah.
Just that.
Hey, you can.
Oh,
Okay? The other way that I also like, because it works for everything,
Mr. Leslie, I just found a key to like
the other way is reciprocal fractions and multiplication. And yes, I do want to show it to you because this will be the key to unlock everything from here on out. I don't even need common denominators. Because do you agree? This is very little work, right? But you still have to make common denominators for it to work. I'm going to show you how to do it. You don't even have to make common denominators. What was my original fractions? What divided by what? Luke, say it. Don't even convert it yet. Originally. What was it? 2/5 divided by 3. Okay, ready? Watch this.
Oh, it's so easy.
Keep this 2/5. Change this to multiplication. And flip this. 2 times 1 is? 5 times 3?
I like that.
We call it keep, change, flip. And after lesson 4, we use it exclusively. Okay? All right. Homework and classwork. Do exercises 1 and 2. Whatever does not get done gets done for homework. What page is that, by the way? So that's your homework. That's your homework.
We have to do the number line, Mr. Leslie?
Yep.
No, I don't want that.
I still want you to model it. I still want you to model it using a number line. No ifs, ands, or buts.